Alright, so GW Phoenix, this is Adrian, and we're talking about the universe. We left off starting to explain vibrations. Um, and we used sound vibrations as a reasonable, uh,
Base.
observable base of how vibrations work.
Yes.
Now, let's start out at the big end this time. Now, have you followed at all the astronomers in their searches for planets?
A little bit. Not much. Beep, beep.
Do you remember how they say that they actually find those planets?
I know that, yeah.
All right. So what they do is they watch the star and they look for a wobble, because a wobble is proof. So they say that there is a planet tugging on it with a gravitational pull. So, you have the star moving side to side just slightly.
Okay.
So, that's how they find planets on stars. Um, now,
Or just name them planets instead of stars.
no, because of how stars are, they're so bright. When you look at them, you cannot see the planets that go around them. So you have to go and find a way. And mathematically, they found that if the star wobbles, that's because of the gravitational pull of the planet as it goes from side to side
Oh,
around it.
okay.
So that, as I would say, would be uh, the largest vibration that we could ever observe. Something that takes, anywhere from 14 days to a million years, because who knows how long it's going to take for a planet to go around a star.
Yeah.
Um, they often do look for ones that go about a year because they're really looking for something that's comparable to ours. That's why they're always looking for uh, Earth-like planets. But we observe this vibration with mathematics and placement and all that. Um, and if we bring it down, we can see how in our own little area that entire aspect works between the moon and the Earth. That's why we have our tides the way that we do.
Yeah.
When the moon is in one position,
Yeah,
the
both sides.
the water often goes towards the moon or away from the moon or both. The highest tide of the day is when the moon is on the opposite side of the Earth as the sun.
Yeah.
That's also the lowest tide for the opposing areas. Um, so with that, we can see a vibration. Also, how the Earth moves, it just very slightly meanders because of the moon pulling it side to side. We're not on a completely and total straight orbit because of that little bit of, pull. Now, as we go further down, we can observe the same connection between the body and the orbital pieces. Once you get down to the atom, it's extremely fast. It's so fast that that is what creates the electromagnetic field. Um, just like creating electric, you have to have a something creating a current through something else. And in our world, that's what the atom does. It continuously goes around itself, always creating energy from its own energy. Um, so with that vibration, you have different types of different types of fields. You have a gaseous field where everything can move around harder substances, uh, thicker fields. You have ones that can allow light to pass through them, and ones that light cannot pass through them. Of course, being water and glass, light can pass through, and clay and coffee, which just happens to be exactly what I have in those two things, um, being not able to have light pass through. But yet, the liquid, a harder substance like our hand, can go through the liquid, because the liquid will go around it.
Displacement.
Yes, exactly. Because our atoms have a different frequency than their atoms, which keeps them separated. Now, in saying the word frequency, it's because it's a constant movement that the atom's making. So it's constantly just barely vibrating at a frequency. Every single item that we have, every molecule type, gold, helium, barium, they all have a different frequency because of the weights that are going around it. So you have one electron, and it's going around the same speed as every other one would, but because it's only one, it is a very distinctive vibration. Then when you have the atomic weight of 2, which means 2 electrons going around, which this is of course helium, and the first one was hydrogen. But helium with 2 around it, the vibration is just a slight bit different, making it a different frequency, a different density. And you can go through the entire thing. Heavy metals are heavy because they have more electrons. Light things are light because they have less electrons. And the power that it creates makes it more or less likely to go towards a larger electromagnetic body, which we call gravity, which pulls us down.
Yes. Which is the planet.
Right. So if we were made up of atoms that had less electrons in it, we could float. I mean, if we were made out of helium, we could float up, and the gravity of the Earth would keep us at just underneath the
Atmosphere.
atmosphere, because that's where our gases begin to stop. So, by how fast the frequency of the vibration is depends on how it is going to try to get to the larger body. Well, is there a better way to say it? Yeah. So that means that every single one of those items is different because of its frequency. A frequency creates a wave, right? A frequency is a wave, a continuous wave, sound wave.
Waves in water.
Exactly.
Waves in your face.
You're weird. So, with these waves, we have wavelengths. The wavelengths are the frequency of how it vibrates, right?
Yes.
Alright, so if we go by this, then that means that the wavelength of this wood is different than the wavelength of the material making up my finger
or fingernail.
or fingernail.
Or
Just
hair,
like
your
as you
hair.
go up into the non-tangible
Okay.
being sound.
Okay.
Those waves are, of course, calculated the same way by the frequency of
The vibrations.
the vibrations.
Yep.
So you go through sound, and then
That's why your eardrums ring when you hear something at a weird frequency.
and then you go up into the areas beyond sound, and you get into radio waves. Now, radio waves are waves of energy. Now, I believe this is caused by, energy being able to move faster than the matter. It's a ripple.
Yeah.
The energy is a ripple. Because everything's connected by this permeable.
Ebb and flow.
No, it's sort of like around us we have just a bubble that goes out continuously, and then every other object does. And however that bubble affects the things around it, changes everything. So it would be like seeing blowing bubbles and having 5 or 6 of them start clumping together.
Yeah, and they don't pop because they're the same material.
So when one vibrates, that one vibrates these ones and those ones, and it all reciprocates all around.
And that's how it gets its strength.
Right. So we have an atom that is, doing this exact same thing. We have solar system that's doing that same exact thing.
We have the universe that's doing the exact same thing.
Exactly.
To our knowledge, there's something else that could be bigger than the universe that could be doing the exact same thing.
That would be possible. And very well likely. I mean, we could just be parts of a larger molecule.
We could be the heel on something that is much, much, much larger than us.
Alright, that's too much out there in philosophy.
But it's true.
Yes. But as we look at this, we have these energy waves. What they are is they're the waves that come off of this vibration. Now we have sound waves, which we are able to perceive with our ears. We have waves that deal with chemical reactions, which is why we can taste things and smell things. And we are able to receive and understand waves of light through our eyes. So we can perceive light by its frequency of vibration.
I'll vibrate your face.
Right?
Yes.
Now, as we go up, there are other waves that are very, very well known. Alpha waves, beta waves, theta waves. You know what those are?
Not exactly.
Those are waves that are recorded for thought. Certain vibrations that your mind makes to create thought. And these waves can be picked up by a machine that only has to touch the skin or be around the skin or be around the body. Which of course shows that we are able to perceive thought from a distance. There's of course a scary thing that can come up from that. Late. So they're able to perceive and possibly understand these alpha, beta, theta waves that are waves considered with thought. Now, with waves, you create energy with waves, right?
Yes.
So the movement of an object creates waves, that is energy. When these waves touch other objects, it creates energy in those objects, which reciprocate the energy back, which is why it's sort of a force field.
Okay.
The tangibility of this object is because of uh, the wavelength created from the atoms.
Bounces back.
Yes, I can't go through this because we're too close to the same, or
Too far apart.
yeah, I wouldn't know how to figure that out. But I can't pass through the wood, and the wood can't pass through me, or at least not very easily.
It requires lots of force.
Right. Now,
It's not like water.
I mentioned for a moment there, of course, light waves. Being that the the reaction that creates the light is actually creating it's creating a field that is expanding outward. So you have an explosion of energy, a nuclear explosion. And what happens is the molecules start reacting, and then from reacting, they move differently, creating light, creating energy, creating heat.
Sound, everything.
Yes, energy in all directions. With this change in vibration, it creates all of this effect that goes outward. Now, different wavelengths of light come as different colors. So it would be very, very easy to say that, what we perceive is actually different. Different wavelengths from a atomic reaction or atom speed of the wavelength, which I can't remember where I'm going with this. I'm trying to explain that every single thing that we have contact with is no more than a vibration caused by pretty much what we see with the solar system, the planets, the stars, the atoms. So it's just creating a vibration, and that vibration depicts what happens.
Yeah.
That vibration is something that we can perceive with the organs in our eyes, with the organs in our right. We can perceive the vibrations. So we're not actually seeing anything that's really there. We're seeing the vibrations from the atoms that we have
put into that area,
put around us. And the different wavelengths, of course, create different colors for our perception. Now, as we're going through this, I'm thinking very, very much about this one gland that's set up a lot like the eyes. The pineal gland. The pineal gland. Which is a gland set up very, very much like the eyes. But now, eyes, everyone says that it's for seeing light. But with what I've just described, we're seeing wavelengths.
which are vibrations.
Right. So, the pineal gland
Which is the same
could
thing as touch.
very, very likely be something that can perceive a different type of wavelength. So,
Which is thought.
thought. Alpha waves, beta waves, and theta waves. There were probably a lot more because there are so many variations on light waves because we have colors.
Also because of the fact that, there's so many nerves that we know of in the brain that we don't know. Most people don't use most of those nerves on a regular basis. There's nerves. There's tons of nerves that you don't regularly use.
Right. But that means that if that organ actually is supposed to perceive a vibration, it has to be able to see a vibration that doesn't need a clear opening to view. So, you've done the whole thing where actually you do it better than me, don't you? Oh, my head. But,
I don't need my...
okay. You know? Our skull in this sense, where we have this very, this pineal gland in the middle of this gray brain matter, which really, oddly enough, is set up almost like the eye. I mean, the brain matter around our, perception organ is almost like the fluids around the perception organs of the eyes.
Mm-hmm.
But that would make our head, our skull, a giant receiver for certain types of vibrations.
Mm-hmm.
Now, this is where I'm just going on a tirade because I'm coming up to different things that I haven't noticed before. But we have vibrations that we perceive somehow with pineal gland, right?
You remember what I said to you last night when I left? I pointed at you.
Cigarette.
No.
No.
I said, open your third eye.
Oh, shut up.
Their third eye is commonly thought by philosophers and such to be the thought perception.
There we go. So, we have come to a place in our talk where we have gone from a perception of science to describing something that has been considered metaphysical in a scientific way.
Mm-hmm.
Damn, that sucks. Somebody's going to want to listen to this, I think. Somewhere. Someday. Alright, so we've come to a conclusion, or
to a
hypothesis that since the eyes are meant to see vibrations of energy that we would consider light, then the pineal gland would be a organ to perceive vibrations, so said as thought.
Or whatever. It could be multiple things.
It could be the other dimension that we can't see right now.
Mm-hmm.
Which the other dimension that we can't see right now, we could consider, heaven, hell. There might be many. Imagine if we were interdimensional beings, and
They
all
could
we
just
need, all we would need to do is just change our view up there, and then there we are in the other place. Uh, we're not going to get into mind altering substances right now.
no. That's not what I'm talking about.
Oh, okay, good.
It could be the whole black hole, white hole concept, where all the atoms and everything in our body are constantly being drawn into itself and then being rebirthed into another being on the other side. That whole, like I said, ebb and flow.
Well, we'll get to that in a few moments because that is actually a description of the energy created by the heart. We'll get to that. I still want to go after this pineal gland. But, but we're actually in the middle of this. You don't need a cigarette right now.
It's not a mind altering substance. Okay, yes, it is.
It's nicotine. Yes, it is. It changes your mood. It slows reactions. The chemical reactions within your body, of course, create certain dysfunctions. You are a dysfunction. Get your
All
hand away from me.
dysfunction, you.
Quit it. Quit it. Quit it. Damn you. Pineal gland. All right, pause.